All right, here in our project, let's add a new class. We call it bubble sort. In this class, we need one method, public void sort. We give it an integer array and call it array. Now here we need a loop to iterate over this array multiple times. In each iteration, the next largest item will bubble up and move to its correct position. So a typical for loop, for I, we set it to 0. As long as it's less than array.length, we increment it after each iteration. Now here we need a second loop, and we use this loop to compare every 2 items of this array. So let's call this loop variable j. We can set it to 0 and start from the first item, or 1 and start from the second item. So here we'll compare the second item with the previous item, okay? So we set j to 1. As long as j is less than array.length, we increment it after each iteration. Now in each iteration, we're going to compare the item at index j with the previous item. So if array of j is smaller than the previous item, that means these 2 items are out of order. So we need to swap them. How do we do that? Real easy. We've done this before. So we use a temporary variable and copy array of j into this variable. Then we set array of j to array of j minus 1. And finally, whatever we have stored in the temp variable, we use that to set array of j minus 1. So array of j minus 1 equals temp. That's our bubble sort. Now, I prefer to extract these 3 lines into a separate method called swap. This will make our code cleaner and more readable. So let's declare a private method here, private void swap. We need to pass our integer array and 2 indexes. So index 1 and index 2. Now, once again, we use a temporary variable. So we set temp to array of index 1. Then we set array of index 1 to array of index 2. And finally, we set array of index 2 to temp. Right? Now, back to our sort method. Instead of these 3 lines, we can call swap, pass our array and 2 indexes, j and j minus 1. Now, because we have a single statement here, I would prefer to get rid of these ugly curly braces. That is better. So we're done with this implementation. Now let's test it. Back to the main class, let's declare an integer array called numbers and set it to 7, 3, 1, 4, 6, 2, and let's add a duplicate like 3. Now we create a sorter object. We set it to a new bubble sort, and here we call sorter.sort, pass the numbers array here, and finally we're going to print this on the terminal. So here we use arrays.toString to convert this array into a string. So we pass the numbers array and run our program. So as you can see, our array is sorted. Now let's test the edge cases. What if we have, let's say, only 2 numbers here? Our algorithm still works. Beautiful. What if you have a single number? Still working. Beautiful. What if you have an empty array? No problem. So we have successfully implemented bubble sort, but there are a couple of places where we can optimize our implementation. Let me show you. So back to our bubble sort class. Here we're assuming that we need n iterations to sort this array. But what if our array is already sorted or partially sorted? Then we're not going to need n iterations. We need fewer iterations. So here I'm going to declare a Boolean variable called isSorted. Now in every iteration, we want to set this to true and assume that the array is sorted. If our assumption is correct, then we'll return immediately. So let's add curly braces here. In every iteration, first we set isSorted to true. We assume that the array is sorted. Now we start comparing items. If we end up swapping 2 items, that means our assumption was wrong. So right after swapping, we need to set isSorted to false. However, if we don't do any swaps, That means our array is fully sorted. So after this for loop, we can write an if statement. If the array is sorted, we can return immediately. There's no need to iterate over this array one more time. That is one optimization. We also have another optimization. Look at this inner loop. Here we are going through the entire array, comparing every 2 items. But as you learned, in every iteration, in every pass, the next largest item bubbles up and moves to its correct position. So we don't really need to compare all the items in this array. We only need to compare all the items that are not in the correct position. So in our first pass, no items are in the correct position. That means we should iterate over all the items in this array. In the second iteration, one of the items is in the correct position. So we need to look at all the items except the last item. So here, we can change this expression to array.length minus I. Again, in the first iteration, I is 0, so we're going to look at all the items in this array. In the second iteration, I is 1, so we'll look at all the items except the last item. So these optimizations make this algorithm run a little bit faster, but its time complexity is still O of n squared.